All right, let's talk about the formal definition of a function. This is the technical definition. All right, we've been talking about it, but this is technical. A function is a collection of ordered pairs, x and y, such that any particular value of x is paired with at most one value for y. All right, we've talked about this a little bit, and we're going to look at it a little more closely. Okay, so here's a function. These are the inputs. These are the outputs. This is function g. I'm sorry, I'm saying it's a function. This is a potential function. And then let's explain why it's not a function according to our definition. Okay, so any particular value of x is paired with at most one value for y. So if you look at this x, you've got, here's 1 point. And then if you look at this x, you've got a different value of y, and that's not okay. So anytime that you have two x values repeat, one x value that repeats itself, I mean, here's another right there. Either one of these would keep it from being a function. You can't have double x values in a function. You can't have them going to different y's. It just is not possible. Okay? So one way you can do it is to use a vertical line test. And let's think about this. If every vertical line intersects a graph at no more than 1 point, then it is a function. So let's just think about if I was going to graph these points, I would put a point at 1, 1, and I would put another point at 1, -1, a point at 2, 2, and a point at, 2, 4. Let's put 4. And another point at 2, -4. Both of these defy the vertical line tests. The vertical line is right here, and it can't go through 2 points of the same function. It's not a function, and it defies it twice here. Okay, so let's look at that using graphs. The question is, which of the following are functions? Explain how you know. And for all of them, let's talk about what the domain and range are. Okay, so let's look at A first. Okay. Is this a function? Well, we take the vertical line test. I'm going to take a little blue. Here's my function. Okay. Now, if I took a vertical line and I put a vertical line on every part of this function, will it ever have 2 points that touch? No. So yes, this is a function. The domain, now we'll talk about this in class, but when a graph comes clear to the edge of the grid right here, that's an implied arrow. Okay, so the domain of this graph means they go forever on this is the x-axis. There's no holes or any problems. So we're going to call that -infinity to infinity. The range, on the other hand, doesn't start until 0. If you look at the y-axis here, it doesn't start until 0 and goes forever. So let's say the range is from 0 to infinity. Okay. All right, now let's look at this guy right here. Is this one a function? Can I draw any vertical line that is going to touch it more than once? No, this is all good. This is a great function right here. So we're going to say, yes, he's a function. And the domain, let's look at the x-axis. Okay, see, they have the arrows on this one. So I know that for every single x value, there's going to be a point on that parabola. So that's also going to be from -infinity to infinity. And every parabola will have that for a domain. But the range is different because the parabola doesn't start until right here, which is at -1. And then it goes all the way up to infinity. So my range is going to be from including -1 to infinity. And let's take a look at C, and we can see, oh my gosh, anytime we put a vertical line, it hits it at 2 points. Not cool, not cool, not okay, not a function. All right. if it were a function, the domain would be, it looks like from negative 1 3/4 to positive 1, whatever that is right here, 1 3/4, negative 1 3/4 to positive 1 3/4, and the range looks like it's about, it's 1, maybe 3/4. That's not a fun one anyway. Okay, let's go ahead and move on. All right, now, and the last thing you need to be able to do is take an equation and decide, is this a function? Is this a function? And the easiest way to do this is to check with the graphing utility. There are ways to learn the tricks that work. Oh, and there's one more. So what I've done is put these in Desmos.com. So I'm going to share Desmos with you, and then we'll look at those one at a time and get a good graphing window. All right, so this one right here is a line, 3x minus 5. It looks horrible. So if I want, I can get a table, but if I just change the grid to, let's go, I wish I could just go back to normal, but let's just go from negative 10. We don't need this. From negative 10. I'm sorry, let's go. And we'll go to positive 10. And this one will go to negative 10. And this one will go to positive 10. It's just a 10 by 10 grid. And then I can play with that as I need to. Okay, does this look like a function? Well, we're going to say yes, because any line is a function unless it's a vertical line, which isn't a function. So, okay, let's turn that one off and let's look at the radical. There's the square root of x minus 2. And it looks like there's vertical line test works. We can't see any points above the other one. So we're going to put yes on that one. Let's look at the next one and close this one. Oh, we got a circle, and we know that's not a function because there are 2 points right above each other. That's even right there, those 2 points. You can't have a 0, 3 and a 0, negative 3. It's just not okay. So that's a no on our circle. And let's look at this one. Oh, that's actually called a cubic, and it's to the 3rd power, and that looks very fine. It almost looks like, yep, there's nothing problem here, so we're going to call a yes on that one. Let's look at this one. It has an absolute value in it. Oh, look at that. Yeah, that's just an upside down V. As far as we can tell, there's no lines that are dots that are above each other. So let's go back and share this. So this one was a line. I'm just going to do a little sketch. Not with that, though. Let's do it with black. A little sketch. So this one was a line. Okay, and that was a function. Yes. This one, if you recall, was square root. And yes, that was a function. This one was the circle. This was not okay. No, did not pass the vertical line test. Let's see, this one was a cubic. It went something like this. And yes, that was a function. And this last one was an upside down, like a V, and that's our absolute value function. Okay, so that one was a yes. All right, so let's talk about one more thing. Well, actually, let's just quickly review. So let's go back to this. All right, so we've got equations, we've got graphs, and we've got tables. And we need to be able to identify which ones are functions and which ones aren't. So let's create 2 tables of 5 points, one that is a function and one that is not. So this one is going to be a function. And this one is not going to be a function. All right, so let's just make 2 points. I'll go fx and f of x. And it says 5 points. Okay, so all I have to do is make sure that the x's are all different. And they can go anywhere they want. -1, -8, -10, -15. I'm just making it up. The only important thing here is that my x values do not repeat. Okay? So, on the other hand, if we want to make a table of values that is not a function, all you have to do is 0, 1, 2, 2, 3, and give these two different values. So it could be 5, 10, 15, 20, 25, and then right here, it kills it. Because you can't have, if you think about that graph, and you graph over 2 and up 15, and then over 2 and up 20, they're going to be above each other, and that messes with the vertical line test. Okay? And last of all, let's sketch two graphs. One that is a function, this is my is, and this is my is not. Okay. And so let's graph one that is, that could be almost so many things, as long as you just don't go above each other. So I'm just going to make it, okay? And let's do one that is not, would be something that goes, okay, that is not a function because I have this right here, vertical line test. Wow, I have 3 points above each other. All right, you can't have points above each other. You just can't. Okay. Okay, I think you're ready to go to the lesson and see what you can do on the practice problems. And then I'll see you in class.